This video is brought to you by the Environmental Protection Agency. The use of any trade names or commercial products does not constitute an endorsement on the part of the Environmental Protection Agency. The purpose of the video is to provide small water systems with an introduction to the use of point-of-entry and point-of-use treatment devices as arsenic removal technologies. Point-of-entry systems and point-of-use treatment devices are technologies that are more affordable for small water systems because they are not sized to treat all of the system's water. Although the technologies have been around for decades, they have not typically been used for compliance with the Safe Drinking Water Act. When Congress reauthorized the Safe Drinking Water Act in 1996, it included a section that made it clear that point-of-use and point-of-entry devices could be used for compliance providing they were owned, operated, and maintained by the public water system. Additionally, they must be equipped with warning systems to notify water users of operational problems and maintenance needs. POU, or POE equipment used for compliance with an MCL, must be independently certified to an appropriate NSF/ANSI standard if one exists. This is a schematic drawing of a point-of-entry treatment system. Point-of-entry systems are connected to the service line of a building and provide treatment for all of the water that enters the building. This type of technology can often be less expensive than centralized treatment because it does not have to be sized to treat water that is used outside the building, such as irrigation water. It may be appropriate for use with microbial contaminants and when exposures other than consumption are of concern. For example, when contact with the skin may cause health problems. This ion exchange water softener is an example of a point-of-entry installation. It treats all of the water that is used within the house, but does not treat water for the outside hose bibs. Point-of-entry treatment systems are likely to be most practical for use at non-transient, non-community systems, such as schools or factories, or small community water systems, such as apartment buildings. This is a point-of-entry system installed in an apartment building in Harvard, Massachusetts. The apartments have their own well and are regulated as a community public system. The well's water is chlorinated as it enters the building to convert arsenic-3 to arsenic-5.
It then enters these four 3.6 cubic foot fiberglass mineral tanks, and each one of these four tanks has approximately 2 cubic feet of activated alumina filled, so it's about, you can see this black line that would be filled to at that point. And there are a total of 4 tanks, 2 tanks in parallel, followed by 2 more tanks in parallel. And then you have these sample points between the tanks. These would be commonly referred to as the worker tanks, where the water first comes in contact with the activated alumina. And if these are doing their job, then if you sample at this point, you should test for 0 arsenic or below at least the level that you're looking for.
The treated water is stored in polyethylene tanks and is pumped from those tanks into the building's plumbing system. The treatment system is sized to produce the system's maximum in-home daily demand in less than 24 hours. Peak demands are met by pumping from storage, and water for outdoor use is untreated. In this way, capital costs for treatment are reduced, but the system incurred additional cost for storage and repumping of the treated water.